meeting together, and so we just kind of covered what we talked about last week while we were on the call. And this week, I believe Alibaba had a use case they wanted to present. And if anyone else has something, please let me know, their PRs they want to cover, etc. Alibaba, are you ready to go?
Okay, I'm ready.
Yeah, okay.
Somebody just share my screen.
Please do, yeah. Is that fine with everyone else on the call?
Yeah, sure.
Okay, great. Okay, go ahead.
Okay. Okay,
Are you presenting, Clark?
We may have lost him.
We may have lost him. Okay.
Maybe when he went to share the screen, he pressed the wrong button.
Yeah, possible. Okay.
Yeah, let me probably check with him. Yeah.
Okay, all right. In the meantime, did we have other PRs we wanted to cover from anyone else's side, Prince or anyone else on the call? I have a list if we want to look at them. Share my screen.
Andy，我刚才那个突然就是浏览器关掉了，我重新进一次，我正在重连啊，稍等我一下。
Yeah, he's back right now. He's somehow
okay.
So now he's back. He already
okay.
Yeah.
All right, I'll stop presenting. Go ahead.
Okay, sorry. Just share my screen. Sharing VS Code. Okay, sorry. Okay, this one. Hello.
Oh, you found it.
Oh.
Good.
Yeah. I don't know how to show this markdown in my browser, so I use VS Code.
Okay.
Just get started.
Sure.
Today we are sharing our scenario of NAT, which we have two use cases actually. One is SNAT for cloud user to access internet service, and DNAT for hosting some service for internet users. And we are trying to and we are sure NAT is a pretty normal use case, and it also include a routing service for the underlay network, and also have the billing service for tolling reason for tolling. So we set up this HLD is for the testing purpose for NAT behavior. The the several key component, several key we are checking is CPS, that's connection setup rate per second, and data processing bandwidth, BPS, and PPS, and also we are testing flow scale. Here we can see a topology here. We are in this HLD, we are using appliance for dash. Which we have a switch and some smart NIC here in the appliance. So we can see VNet 1, we have a VM1. When VM1 is accessing the internet, we are using SNAT service. And if use case 2 is DNAT. For example, we host service in VNet 2, in VM2, reside in VNet 2, and internet user just access this service in the cloud. So DNAT is used. So far so good for the topology.
I think so from my end. Anyone else have a question on the descriptive part?
Okay.
I guess we keep going.
Okay. Yeah. So we present the first use case, that is SNAT scenario. First of all, when VM send traffic to the appliance, we will determine the direction of the packet. If the VXLAN header is present, we think it's an outbound packet. So the first thing we do is to look up the flow table, the outbound flow table. If we found that, we go through the fast path. Just take the action of replacing the source IP and source port and do the decapsulation of the VXLAN header, and then use the inner header to do the routing lookup and do metering and counting, and then send to the packet to the internet. And counting and metering is optional. If we at this point, if the outbound flow lookup is failed, we start the slow path. First, we look up the SNAT rules table and find a new pair of source IP and source port, and then we do a VTAP lookup to find the VTAP IP for the responding packet to set up the inbound flow table. And then the next, we use the information we fetched in the slow path and set up a new entry in outbound flow table and inbound flow table. And then the rest of the action is the same as the fast path, but it's but it's done in software. Usually, the fast path, we have a hardware table here. It's not necessary to be a hardware table, but usually it is a hardware flow table. Any feedback?
Just as a comment, we don't generally view fast path and slow path as one being in hardware, one being in software. In fact, we always view everything being in offload. that slow path shouldn't be much slower, and it can still be a hardware offload. We don't say slow path is software or fast path is hardware. It's supposed to be in Dash. Everything's supposed to be a hardware offload. So we define the functions, and then we allow the suppliers to figure out how to do those functions as a hardware offload. We don't even really talk about software versus hardware because the implementation is specific to devices on the market. They're all different, but my point is we don't say fast path is hardware, slow path is software. In fact, they're both hardware offloads in our minds.
Yeah. Sorry. That's true. Because slow path can also be done in the hardware, but it takes more steps than the fast path only. You're right.
We view it as being more slow path to us means just it's more complex and there's more stages, there's more things to do than in fast path. But that's all we mean by slow path. It's more complex for sure. But we don't associate it with software or hardware uploads. It's just more complex work.
Yeah, I got you. Yeah, that's true. Slow path only take several more steps. Okay.
Yeah.
Okay.
Do we also do the ENI lookup, VNI lookup that is defined in Dash before the first outbound flow lookup?
Here we don't.
Don't do
we
any
only
lookup?
care about the directions.
Sorry, what about direction, please?
The direction only takes in the first step. For example, we treat VXLAN encapsulated packet as outbound packet for SNAT case.
I see. So inbound will not have VXLAN encap?
Yes. It's backward. It's responding packet.
Okay. The flow lookup happens before the SNAT rule lookup?
Yes.
First flow lookup.
First, for example, if the first packet comes, we a lookup outbound flow table lookup must fail, and then we do the SNAT rule lookup to obtain some information to create the outbound flow table, and then the second flow belongs to the same flow arrive, and we look up into the outbound flow table, and we may get a hit, and then do the fast path processing.
Yeah, I thought that the SNAT lookup might come before the first outbound flow lookup as well. That's what I had thought. Okay.
Yeah, in this way, we only look up SNAT rule once. And then we always want the fast path, right? But first packet comes, it must fail. And then we go through the slow path and establish everything.
The deployment, the background is this deployment scenario will be different because we put as the gateway. So between the cloud and the public internet. That's why, like say, we were using the VXLAN encap as a packet as a decision to say it's outbound or inbound.
Okay.
Okay, sorry, I missed something in this topology. Yeah, here actually we are the appliance is taking the role as a gateway. So yeah, I missed this part. Sorry. So that's why the SNAT pipeline
Can you go back to the topology?
Okay, here.
I think it may be helpful if you draw the dash device, somewhere, right? So, this, okay. Your appliance is different from the dash appliance, right? So therefore, you may draw your NAT appliance here, and then there is a VM that can go to the dash appliance and then go to your NAT appliance, right? So I think that is a topology. Maybe you draw it, so then we have a clear connection, how this is related to the dash, or right? So maybe that clarifies.
Yeah. Okay. So this topology is simplified. So I can add another more comprehensive topology here in the as the architect as the network architecture.
But Guohan, this appliances is a dash appliances, which is a smart switch. That's why he drawing.
Yeah, no, I get that, but the usage is different, right? So the physical entity, is different, right? So
yes, the physical entity is different. Yeah. So this one is different from the current dash use case, which because
that's what I'm talking about. So yeah.
Maybe another picture showing the role of the dash appliance may be more clear.
Well, first of all, if you want to call it a switch, then just call it a smart switch and not an appliance, because they're slightly different.
And actually, this guy will have multiple DPU or some hardware reside on this appliance. It has a switch, and it also has multiple cards.
Yeah,
how many RU is it?
It doesn't matter how many RUs. That's our definition of a smart switch. It has multiple DPUs on a switch. So think of it as, in terms of switching layers, a tier 1 400 gig switch, 12.8T with multiple DPUs on it. That's what we call a smart switch. It's not called an appliance, because an appliance is really a server that holds multiple DPUs. So that's an appliance, and a smart switch is a switch which holds multiple DPUs.
Okay.
Yeah, we will change the name. Say we should not call it appliances. We should call it a smart switch.
Yeah, and also, from a hierarchy of software and stuff, the switch is running SONiC, and it has multiple DPUs, and they're all running SONiC and dash. So I think it is a smart switch, what you're talking about. And it could, as reference, it could sit at a tier 1, or it could sit anywhere in the data center, by the way. Because we tunnel, all those VMs got to tunnel to it anyways using VXLAN or something, some tunneling mechanism.
And I just a small piece. I put a little piece of artwork in the chat window, and you could attach it to your switch to denote that it's dash, like we do in our HLDs.
Okay.
Or whatever you want to do. Just a suggestion.
Yeah, no. It's good suggestion. That may be more clear for people to understand the usage or the role of this device. And this is actually a smart switch as previous we are talking about. The name, we may change it to make it more clear. That's okay? Yeah. And
maybe they can use some of the pictures that we already have in documentation for smart switch. Christina, maybe you could just help them find that. And that way people know that it's just I think you're talking about a standard smart switch, so it's not something new there, and then that will just make it more easy for people to understand.
No problem.
And it'll be easier for them to scope out and show all the containers and where they are later on when we get more deep into this.
Link to it.
Sounds to me that they're talking about doing the regular, kind of trying to do the regular path, but adding they're adding this NAT functionality to when you don't find a fast path entry. And they're just, the slow path is what they're trying to define. I don't think it changes anything in the architecture at all. It's just, what are those steps in the slow path that need to get done that are different than what we talk about today? I think that's where the uniqueness is. And I think we all understand that. I mean, doing NAT and SNAT, we haven't defined that. So they can, so I think that's fine. I'm not sure that the fast path actually needs to change much. It's a slow path that needs to change, or at least add this functionality.
The fast part will be, because here we don't need the V9 lookup, so that's why like we want to like probably have a separate like a model for that purpose. Because that's why like, we specify to say, hey, there's we using the VXLAN incap to as a determination for, say, this is the outbound traffic. So because normally you do the VNI lookup first, then policies are applied on the per VNI, but this is a global policy. So that's the main difference.
Yeah. So I think I see that it is slightly different from the other model, like what we have in the other SONiC HLD. So in this, there is no ENI lookups, right? Like Reshma asked, and these tables are not associated to ENI, right? It's part of the VNet thing. So I'm just trying to understand like how you associate this VM packet to a VNet.
Actually, we use the VNI as part of the key to determine what VNet this packet belongs.
Maybe you can continue on the inbound finish, then we can see the more detail on the flow. Yeah.
Okay. So let's take a look at the inbound packet processing. When the responding packet comes from the internet, we determine this is the inbound packet processing, and we first thing we do is to look up the flow table, and then because the table entry is created in the previous slow path, and then we may have this lookup hit and do the replacing the destination IP endpoint and do the VXLAN encapsulation. The VXLAN encapsulation data is actually fetched from this guy, VTAP lookup, to obtain the destination IP of the VXLAN header, and then we use the encapsulated packet to do the routing lookup, and then send the packet back to the VM. This is the reverse path of packet processing. So one thing I want to say is that here the VTAP lookup is to create the table entry in this guy, in this inbound flow table.
Okay.
Okay. So any question?
So in the inbound, there is no slow path?
Yes, because if a packet lookup in inbound flow table lookup failed, it's dropped for the SNAT processing. SNAT processing will drop that packet.
But you have DNAT, right?
Yes, it's another case, right?
DNAT scenario should have the exception pass, right?
Yes, DNAT is a reverse, another story. So, okay, if this is fine. We can go over the DNAT, and then we may discuss later. Okay, go ahead.
Yeah, but I think ultimately you will combine this SNAT and DNAT into one single pipeline, right? So you will not have two pipelines.
Yes, because we just separate them in two use case, so we can describe the logic separately. So I think that may be more clear for each.
So two
Okay.
use cases to describe the logic, but ultimately converge
Yes.
the pipelines.
Yes. And SNAT lookup and DNAT lookup, they have different IP addresses, so we can distinguish them, right? For example, okay, let's talk about DNAT first, and then we may know how to distinguish these two kinds of packet. Okay.
Sure.
Okay. So when in DNAT scenario, the inbound packet is from the internet. We determine this if the packet income from the internet has no VXLAN header, we think is a DNAT inbound packet. We first do the lookup in the inbound flow table. If we do find it, just replace the desk IP and port and do VXLAN encapsulation and do the routing, and then send the packet to the VM. If the packet missed, it do the DNAT rule lookup, and then do the VTAP lookup, and then use the information obtained from the previous step and set up the new flow table of inbound flow table and outbound flow table here. And when the VM is sending the DNAT outbound packet, sending the packet out, we look up, we see the VXLAN encapsulated packet. We do the outbound packet lookup, and then because this entry is already set up, we must hit and replace the source IP and port, and do the VXLAN decap, do the routing using the decapsulated packet, and then do metering and counting optionally, and then finally we send the packet into the internet. So in the outbound flow processing here and the outbound flow here. In these two pictures, we can see the packet incoming from the internet, right? So for the SNAT lookup, for the DNAT lookup, we first look up in the inbound flow table. The inbound flow table, the IP addresses, if we host the service in the in this VM, right? Sorry. Okay, in this VM, for example, we host the service in the VM2. We may configure a set of IPs, set of IP addresses in the to the public internet, right? So we may have a list of IP addresses for DNAT lookup. So when the packet comes from the internet, we may have a miss on the inbound flow table, and then we do the DNAT lookup, and the DNAT lookup may create the table in may create a table entry in the inbound flow table. So if an internet packet comes and it does not match the DNAT inbound flow and does not hit the inbound flow table, SNAT inbound flow table lookup, the packet is dropped.
Hey, I have a quick question. How do you decide whether you should go to the slow path versus stay on the fast path in this inbound DNAT scenario?
Inbound DNAT. Okay. If we look up in inbound flow table and get it does not hit.
So there's no entry in the lookup table.
Yeah. Sorry. I'm trying to make it more clear.
Okay.
If the packet comes from the internet and we look up in the inbound flow table of DNAT and we don't find anything hit, we may trigger this packet go through the slow path. Yeah. And then the slow path will do a set of several steps. For example, to look up the DNAT match IP and D port, and then we may then do the VTAP lookup for the encapsulation destination IP, and then we use this information to create the inbound flow table first. So then the next packet, the second packet or later comes to access the same service hosted in the VNet2, VM2, we may hit this inbound flow table lookup and go through the fast path.
Clark, one question. So in the SNAT scenario, right, actually we determine the VNet using VNI. How will we determine the VNet in the DNAT inbound case?
VNI okay. Because we have this guy, right? The VTAP lookup. Actually, this DNAT rule contains the host, the VNI for certain service. For example, we have service A running in VNet1 in VNet2 VM2. So this DNAT root table may contain this information. Yeah, maybe may contain information to make this lookup happen and get it correct.
So
the IP.
The VTAP lookup will give us the VNI. That's what you are.
Oh no, sorry. This one, only this one, and the IP.
Okay.
Using for it's used to do the VTAP lookup.
So I'm still trying to understand something basically here is that if there was inbound flow lookup were to fail, would you not basically drop this thing? Because if you look at the outbound scenario, I mean, I would think that your outbound
outbound DNAT or
so the outbound part would create an inbound reverse flow, isn't it?
In DNAT case, the inbound flow triggered the creation of inbound and outbound flow table. And in SNAT case, it's the reverse. Yes.
Okay. And then how do we, I mean, in the case of, let's say, DNAT, you're showing this inbound scenario. How do you determine the direction? How do you know that it has come from the internet versus from the VM?
Yeah, we only look at this one. If we have a VXLAN header, it's not from internet. For in DNAT case, sorry, in DNAT scenario, we only determine the direction based on the absence of VXLAN header. If the packet don't have a VXLAN header,
I think this should be based on a VNI value, not based on the VXLAN header or not, right? If it matches the VNI, then you determine the direction. Because
the direction is always based on the VXLAN header is present or not, because this is the gateway. So if coming from the internet, it always be the inbound, right? Otherwise, it always be outbound.
I mean, my point is like the same thing, right? Like if you can look at the VNI and determine the direction.
The VNI actually lookup happens here, DNAT rules.
Yeah.
Because when for example, if I host the service, finally we will have a IP for that. We actually here call via virtual IP. The virtual IP is for that some kind of service.
I think they are assuming that from the internet there is no VXLAN packet, right? So then therefore they just use that.
Yes.
Yeah, but I think that's what I'm a little concerned about. Like, so typically we can use the VNI to determine the direction, right? If it matches the one in the rules, then you can determine the direction based on that.
Here we are putting a gateway, right? The gateway is a concept towards the internet. That when traffic comes from internet, there's no VNI at all. Like this is the gateway use case.
Yes.
But could be that either that from internet, if the customer want to, doing some VXLAN encapsulation, then it could send a packet with VXLAN, right? So
yeah, I mean, why we have to restrict for that?
That's a good point. Right now, I think in Alibaba, we never see that kind of packet. Because in general, we assume like a VXLAN should be like say within the inside the cloud.
I think this should be our use case limitation or some kind of assumption here.
Yeah.
Because here from the internet to this NAT gateway is not directly connected. And here in this point and in this gateway, we can in our network we can assume that any packet incoming from this device.
yeah, no, I think that's fine, right? So we can just get some classification rule. If some user need to use a VNI to do the classification, we can have some additional P4 blocks to do that classification and doing some enable disable, right? So then you would meet the Alibaba use case as well as others use case. I don't think that's we just need to close those details later, right? So but let's try to finish the overall picture. But I think that is definitely addressable, right? So Prince. And if someone want to use a VNI, we can add additional block and to enable or disable things, right? So I mean,
yeah, only put it in the first step, because the first step in this NAT HLD is determine the direction of the processor.
Yeah. That's fine.
Okay. And okay, it's that's all for the pipeline. And then do we have any more question, or we can go we can continue?
Oh, maybe I think on the pipeline that maybe we should add some graph to see, okay, how do we differentiate the ingress, DNAT and SNAT, right? So those kind of things, because you put them separately, but ultimately when you put the one P4, you will get them converge, right? So there's some classification to determine whether this is DNAT or SNAT, right? So
Yes.
yeah.
Yeah.
So like a high level at the top of the document saying what we're attempting to describe as SNAT versus DNAT and what we use, something like that, Gohan?
I mean, there must be some classification first, knowing that this is DNAT or SNAT.
Yes, you're right. And actually, we
I think we mentioned it somewhere here. I remember like
Let's have a look.
Basically, we determine either we do the DNAT rule lookup or we do the SNAT rule lookup, because after the inbound flow table miss. So,
okay. Actually, here we can combine these two together. For example, first we do the DNAT inbound flow table lookup and do all of this. And if here DNAT rule lookup fail, we can do another thing, right? Because in here we may just assume that the DNAT rule lookup may be is successful, right? And then we can do the creation of the flow entry. If this lookup fail, we can also do this guy.
Oh, then I don't understand, because when you do the DNAT rule lookup, you already moved to your exception path and you're coming back to the fast path, right? So I saw you will do the kind of fast path first for all the flows, and then and then right. So you don't want to fail and then go back to the fast path to do another SNAT flow lookup, right? So
I think they can chain together because slow path is related to, for example, in this case, it's DNAT scenario slow path, but the fast path of the SNAT inbound.
It's not that efficient, right? If you're saying all the traffic for SNAT will go through the fast path first and then go to a slow path to do a DNAT rule lookup and then go back to the fast path for the inbound SNAT flow lookup, then that's not efficient, right? So for all this SNAT package will go through the slow path, which is not efficient, right?
And
no. Basically, it's like an inbound flow table lookup first. Then based on inbound lookup hit, if it's a miss for the SNAT case, we also trigger the DNAT lookup, but then it will be also failed. Then it will be dropped. So basically, here we probably need to add, like I say, for the slow path, because normally this should be always draw. That's why we didn't draw that diagram. But once these two combined, then you have the DNAT lookup for the fail case anyway.
Yeah, at this picture is more reasonable, right?
Mm-hmm.
So and I think it's somehow for the DNAT rule lookup, why that has to be on the slow path?
Because that's because we consider the flow lookup as the fast path, right? Then if the miss.
But when you say slow path, is that done by P4 or not, or done by the ASIC or done by the ARM core?
Yeah, previously we don't. We think all of them may can be hardware can be accelerated in hardware. All the path.
It's really depend on the hardware the devices we got, right? That could be like purely the slow path. What we have here could be purely in the software, or could purely also be in the hardware. It really depends.
I think, Gohan, this is the exception path, right? It can be.
Yeah, this is exception.
But you in the P4 program, you will describe all this, right? So in the P4, the reference pipeline, you will describe all this, right?
That's true. Yeah,
Okay,
reference pipeline
okay.
will drive all this, but
All
Yeah.
right. Okay.
Yeah, they will be combined together.
One quick suggestion, basically, I don't know, maybe as in the DNAT rule lookup, right? Maybe we can say what is the key, what will be the output. And I think if you put that, right, that will be more clearer what is the exact outcomes.
yeah, we have
Yeah. Yeah, actually, we have this in the rest of this HLD later.
Okay. Okay. Okay.
The rest part.
Okay.
Okay.
Thank you.
So how are we doing on time, Clark? It's
Okay.
we've got about
Yeah.
10 minutes left. So how are we
Yeah,
looking here?
Okay. So
Oh,
we
config examples. Okay.
Yeah. So
Mhm.
we continue. So
Mhm.
there's some table definition. For example, we have some 2 VNAT, VNAT1 and VNAT2, and we define the VNAT encapsulation is static VXLAN, and then we describe some overlay routing table here. Routing type is encapsulate this VXLAN header, and this one is another rule. And then we have a dash SNAT rule table. For example, the source IP is this subnet, and then we go to the destination is all. And then we have a list of usable IPs here. And then this one is similar, but for different source subnet. Okay, and then we just have a overall concept here only, and then we have a VTAP table like this. It's a list. So we see an example of the SNAT first packet. SNAT first packet also refers to the SNAT SNAT outbound slow path, right? No, sorry, the fast path and slow path described here. So when VM1 with IP 10.1.0.10 and go to the internet, it first because it's the first packet, it must go to the go through the slow path, right? So we look up to the SNAT root table, and we have a VNAT and the source subnet, and we got this to any DIP. We have this list of IP usable, and then we do the overlay routing table to look up when the DIP is 30.00.22, and then we have this table look up, and then we use this table. We use these two information to create the outbound flow table first. We have the inner IP and the usable, and select one of the source IP that is 111.1.1.237 and an export and do the VXLAN decapsulation. This is the action of this is the outbound flow table of.
So how did we choose the export?
Which one?
The export.
Export is export.
Yeah, like the.
Okay.
Yeah, since you're rewriting export, so I think the question is how did we get that?
Yeah.
Is this
Sorry. I will go through these guy.
it should be in the config. I think probably we didn't put in the config.
Yeah, we did not show this configuration, right? it should be it should be a configuration, because the source IP list and the source port list should be in some table.
Yeah.
Yeah,
And
it should be in the SNAT table lookup.
Yeah.
And then okay, and then this is the reverse inbound flow table, and we put this DIP 101.1.1.237 and export to map to a D port example, and this is the protocol, and this is the action. Action is rewrite IP and the VNI and the VSN in cap or some this information. This is the first packet, and then the second packet of the SNAT will go the slow path, the fast path. Sorry, it will go through the fast path, because the lookup hit and find the action, and it do the decap action and route the packet out to the internet. And then the reverse path, when the internet packet with the DIP 101.1.1.237, it will find the entry hit here and do the action at the encapsulation, and then send the packet to the and route the packet out to the VM1. This, okay. This is the SNAT processing with table, and then for the DNAT, the first packet is for the internet comes a packet to the gateway, and we go through first. We must have a mist, and then we go through the slow path, and we look up the DNAT root table to find the test IP and port, and then we have a route here and have a overlay route table lookup, and we find that the IP and find that we should encap this packet with this information, and then we first create this inbound flow table for the DIP and D port, and then we do the action in this slow path, and then route the packet to the VM. And the next packet visiting the same service will got this inbound flow table hit and do the fast path processing.
Hey, Clark, one question on the previous one.
Okay, this
Can
one.
go.
Yeah.
From the internet, the packet will come with VLAN header or without VLAN header?
Without VXLAN header.
No,
VLAN, we don't have a VLAN. Yeah, it's untagged packet.
Okay, so how is it possible that that same interface can be used for multiple VNet?
The same interface for multiple VNet.
In that case, how will you get the VNI ID? If it is, how will you differentiate?
In the case we describe here, we have one VIP is unique, so we don't. In this case, it should be the VIP is public. It's global, right?
So you mean to say it? My question is, how will we determine the VNI from this? Because we have to determine the VNet. So VNet has to be determined from either from VLAN or physical interface.
No, it will be based on the VIP look and the DIP lookup, because
Okay.
this is a public VIP, right? Then that VIP determine the service. That service also have the associated with the VNI.
Oh, okay. So basically, either from the source IP or destination IP. So I believe it should be source IP.
Destination IP.
It's a destination IP, right? Because this is the NAT case.
Okay. Okay.
Yeah, it's destination IP. It's global IP. It's not associated with any tenant or something.
So
like
there
that.
would be one more table which will actually determine this map table will be there, which will say that destination IP to VNet, or it will be part of this. Okay, fine.
Yeah.
I think he put in the config. It should be also put it here to showing like the VNI. It's get after the DNAT lookup should be providing the VNI also. Right now we only have the address.
I think we need the clarification in the document, like how do you map this 111 to 190, 195 to VNet 1? I think that's not clear from the document. So
it's in the config, I believe. But
but to VNet 1, the point is how do you map this destination IP to VNet 1, right? This rule is part of VNet 1, right? But in order to look up into the VNet 1, you need to identify a
no.
sort of
this VNet 1 is a result from there. So based on DIP lookup, it's VNet 1 because that's DIP, the VI, it's a VIP basically.
Yeah, but which table will tell you? Okay, I think that clarification is missing.
Yeah.
So
if you go back
I hate to break in, guys. It's 10 o'clock. Do we want to keep going, or does everyone have 10 o'clock meetings?
Yeah.
Because I would love to pick this up next week for a half hour if we want to keep going through it. Or what do you guys think?
Yeah, I think next week.
Next week is
okay.
better.
So what I'm going to do real quick, is just share my screen so that you guys can you see my screen? So this is PR348. It's right here, and be pretty easy to go ahead and go in and make some comments or suggestions. But I've been looking through it while we've been talking here, and just go here, do a view file, and take a look at it and see where you think these little pieces might help in understanding and make changes and put it in a PR, or I guess send it to Clark and the guys from Alibaba. What do you guys think? Good. And I put it in the chat window.
Yeah, so one comment is Clark. So what's your plan to upstream this one to the SONiC community, or this just keep in the desk? I think that's one question. Okay. I mean, it's not urgent.
We can talk about that next time then. I'll write that as a note, Yanzhao. So why don't we carve out, you guys, 20 minutes, 30 minutes from the next session? Is that okay with you, Clark and Eddie?
Yeah, okay. I think
okay, fantastic. Okay, thank you guys for this enormous contribution. It's amazing and a lot of work. I appreciate it a lot. I'm going to go ahead and stop the recording, and I'll post it to the channel, and hope you all have a great